Okay, so let's take one example over here. So this particular case we can just copy paste. Okay, this part we can do, okay, at least. Okay, so okay, then we'll take one of the example over here. Okay, so this is over here. Okay, so we can see, like, so if we take the plus ones at one side, so plus 1 plus 1 plus 1 plus 1, okay, and then so 4 plus 1 and then minus 1, okay, is equal to 3. We can write like this. Similarly, we can take this all these things as s1. We can write like this, s1, this is the subset 1, and this part we can say like s is s2, okay, and these 3 we can mention as target. Okay, now s1, if we add 2, s1 plus s2, okay, so this is total sum. So this total sum, if we add two subsets, then we can reach total sum. Okay, now if we sum these two equations over here, then what we'll get, so over here s2 we can omit, s2 will be omit. So basically what we'll get s1 is equal to target plus, so 2 of s1, 2 into s1 is equal to target plus total sum. Okay, so now s1 will be total target plus total sum by 2, we can say. Okay, this you can write, right? So in this case, like if we can get the count of subsets having this target, then we are good over here, right? So you can say tar is equal to, we need to match a target over here. So target is target plus total sum divided by 2. Okay, and in Python we can say a floor operation over here. And if it is not divisible by 2, if target plus total sum is not divisible by 2, then we can say we cannot reach target, we cannot make target. So target plus total sum modulo 2 is not equal to 0. If it is not divisible, then we cannot reach target, we cannot reach target. Okay, so return 0. So this part is done. Okay, next, so now we can have one function. So we can have a DFS function over here with two parameters, index and current target, typical knapsack. Okay, so base case we will write later. First we'll take the exclude and include case. So exclude case is like, okay, so we'll be moving to next index, so DFS of index -1, and current target it will remain same as you have seen before, typical knapsack. I think spelling mistake over here, exclude. Okay, and include case, when we can take include, so if nums of index is less than or equal to current target, then only you can take. Then include, we can say initially include will be 0. Okay, so now include over here would be DFS of index -1, current target minus nums of index, and as we need to return the count, so then we can say return include plus exclude. Okay, now we need to write the base cases. Okay, so over here what we have done, over here we have made choices, either we have taken the element or we have not taken the element. Okay, now base case we have to write, if index we are starting from right to left. Okay, so if index is equal to 0, then we can say like if nums of 0, the index at the 0th the element in 0th index is equal to 0, or or rather, or we can say, and if the current target is 0, then how many subsets, how many ways we can reach the target? Okay, so either we can take plus 0, okay, or we can have an empty subset also. That in that case also we can reach the target. Okay, so in this case we can say return to. Okay, if another case, if nums of 0 is equal to target, or current target is equal to 0. Okay, so nums of 0 is equal to current target if the 0th element is matching with the current target, or the current target has become 0. It's not like we have to be the nums of 0 is equal to 0. So in that case we can simply return 1. Okay, so we can reach to the target. One way we can reach to target, and neither of the above cases is valid. So then what we can say, like we can simply return 0, right? Okay, so now we can call this function return dfs of we can have n is equal to length of nums. Okay, so dfs of n minus 1, we are starting from right to left, and target is the current target. Okay, let's try to run this. It's running as well. Okay, so again what we can do, like if we try to draw the recursion tree, then we'll see that there are overlapping subproblems. If we are having overlapping subproblems, then what we can do, we can approach for the memoization, okay, or top down dynamic programming, or larger to smaller problems. Okay, so in this case we can have declared dp table. Okay, and what will be the default value? So you can have none. Okay, and size would be tar plus 1. So this will be the inner list or array for items in range n. Okay, so now we can check like if it is already memoized. Okay, so in that case, if dp of index current target is not none, return dp of index current target. Okay, and over here, before returning, we can say like this part we need to store. So over here this is done, and finally we can return dp of index current target. Okay, it's passing as well. So what will be the time complexity for this? So now we are taking memoization over here, so memoization. Okay, so in this case time complexity would be O of n into target, where target is basically, or you can say O of n into s, where s is equal to target plus total sum by 2. Target plus total sum by 2. Similarly, space complexity would be O of, we are using a 2D DP table over here, O of n into s, and over here also will be S will be target plus total sum by 2. Okay, plus we'll be having an auxiliary stack space also plus O of n. Okay,